So if you think you've got a handle on AI just because you've used a chatbot, well, you're going to want to stick around. We are about to dive into the next giant leap in artificial intelligence, AI agents. And these aren't just tools that talk back to you. These are autonomous systems designed to act for you. Let's get into it.
Okay, the best way to wrap your head around this shift is to think of it like this. You know those large language models, or LLMs we're all familiar with? They're the thinkers. You give them a prompt, they chew on it, and they spit out a response. Some text, some code, maybe a picture. But an AI agent is a doer. It goes way beyond just responding. It actually perceives its environment, it makes a plan, and then it takes real action to get something done. And that right there is the crucial difference, that leap from thinking to doing.
To put it even more simply, just imagine for a second that your to-do list could actually, well, do itself. You're not just asking an AI to write a summary of an email. No, you're telling it to go into your inbox, figure out which emails are important, draft the replies for you to approve, and then go ahead and schedule the meetings they're talking about. That is the fundamental promise of AI agents.
So how did we even get here? I mean, this didn't just happen overnight. Let's take a quick look at the journey that took us beyond the simple chatbots to the rise of these agents.
All right, so if we're going to get a little formal for a second, researchers define an AI agent as an autonomous system that perceives its environment, reasons about actions, and executes decisions to achieve specific goals. That's the key right there. Perceive, reason, and execute. That's what really separates them from the older forms of AI. They are built from the ground up for action and autonomy.
You know, this whole idea of agents has been cooking for decades. Back in the 50s and 60s, they were pretty basic systems, just following rules that humans wrote by hand. Then you fast forward to the 80s and 90s, and they started to learn through trial and error. The 2010s, though, that's when things exploded with deep reinforcement learning. That's when we saw AlphaGo beat the world's best Go players. And that brings us right up to today, where these huge language models are giving agents the power to reason and act in our own complex human world.
So, how do they actually work? To really get what makes these new agents tick, we've got to pop the hood and take a look at their anatomy.
This diagram here really lays out the brain of a modern agent. Right at the core, you've got a large language model that does the reasoning. But it's all connected to these other crucial parts. There's a memory module for remembering stuff both short-term and long-term. There's a planning module to break big goals down into smaller steps. Then you have a tools module, and this is super important. It lets the agent use software, connect to APIs, or just browse the web. And finally, an action module to actually do the things in the plan. All these pieces have to work together to turn a simple goal into a finished result.
But how do they get any better? Now, this is where it gets really fascinating. There are these frameworks, like one called reflection, that give agents a way to improve themselves. After it takes an action, the agent can look at the result, reflect on what went wrong, and then generate its own feedback. It's basically talking to itself, figuring out its mistakes. This self-reflection then gets stored in its memory so it does a better job next time. It's just a brilliant way for agents to learn not just from data, but from actual experience.
Okay, that's enough theory. Where is this technology actually being used? Let's look at some real-world examples of these agents at work.
In business and industry, the impact is already huge. I mean, just try to imagine the mind-boggling complexity of a global supply chain for a company like Amazon. Agents are now optimizing these systems, forecasting what people are going to buy, and even rerouting shipments on the fly because of traffic or weather. They're quickly becoming the invisible, intelligent backbone of a lot of companies.
And in education, the big idea is personalization at scale. Imagine an AI co-learner that works right alongside a student, giving them feedback that's tailored just for them. Or think about medical students practicing on simulated patients in super realistic scenarios. All of this frees up human teachers to focus on what they do best, mentoring and higher-level instruction.
The potential in science, though, might be the most profound of all. We're moving beyond just analyzing data. We're starting to see the beginnings of the AI scientist, an agent that could potentially automate the whole research process, from coming up with a hypothesis to designing the experiment and even writing the paper. This could just fundamentally change the speed of discovery itself.
So, with this kind of power, it's pretty clear that agents won't just be tools. They're going to be participants in our economy. And that, naturally, leads to some pretty big questions about the future of work.
And of course, here's the big one, the question on everybody's mind. Are AI agents going to take our jobs? Well, the answer is complicated. And it means we have to think about the economics of all this in a really structured way.
Economists who are studying this space have come up with a few key principles. First, agents don't think like we do. They operate without emotion, without bias. They are just ruthlessly optimizing to achieve a goal. That's fundamentally different from us. Second, most agents are going to act as proxies for people or companies, not as totally independent beings. They'll also specialize and form hierarchies, kind of like human organizations do. And finally, and this is a big one, all of that incredible efficiency they bring has to be balanced with safety and smart regulation to make sure they're working for us, not against us.
The potential here is just enormous. But let's be real, we're not quite there yet. Let's finish up by looking at the key challenges and the future directions on the road ahead.
But there are still some major puzzles to solve. I mean, how do you make sure an agent is safe and robust out in the messy real world? How do you get it to learn a new task without having to retrain it from scratch every single time? And this is critical. As they get smarter and more complex, how do we make their decisions understandable so we can actually trust why they're doing what they're doing? Looking forward, researchers are exploring some absolutely incredible ideas. They're actually taking inspiration from neuroscience to build more efficient brain-like systems. They're trying to solve something called catastrophic forgetting, which is a fancy way of saying they want agents to learn new stuff without wiping their old knowledge. And they're even building hybrid models that combine the pattern-matching genius of neural nets with the cold, hard logic of symbolic AI. Basically, they're trying to get the best of both worlds.
All of this brings us to the ultimate question. AI agents are evolving really fast, from being simple tools into something that looks a lot more like autonomous partners. And yes, they have the potential to help us solve some of humanity's biggest challenges. But as we hand over more and more autonomy, the single most critical task for us will be to ensure that these powerful new doers, that they remain aligned with our human values and our goals. What do you think?